Hello students, welcome to lecture series on agrochemicals and pest management. In this episode, we will be studying about penetration and distribution of pesticide residues and their effects on quality of human life. Toxicology is the science of poisons. Paracelsus, who lived from 1493 to 1541, wrote, "All the substances are poisons. There is none which is not a poison. The right dose differentiates a poison and a remedy." Paracelsus was right. Few substances that can be observed through the skin, inhaled or ingested are truly inert. Many substances that are harmless or even beneficial in limited quantities or with some exposure routes could be considered poison via an alternative exposure route. For example, thousands of gallons of water are harmless when swimming in them for an hour. But if you consume as little as 2 gallons of water in that same hour, the water becomes a toxic poison that will probably kill you. Salt that seasons our food becomes a poison if taken in excessive quantities. Even oxygen, which is a necessity of life, becomes toxic at extreme concentrations. It has been said there are no harmless substances. There are only harmless ways of using substances. This is generally true and a very important concept. Hence, in this episode, the following aspects are going to be seen. They are pesticide toxicity and hazards, types of toxicity, pesticide residues, pesticide affect humans, and symptoms of pesticide poisoning. Going to the first aspect, pesticide toxicity and hazards. In terms of pesticide safety, there is an important difference between the words toxicity and hazards. Toxicity refers to inherent poisonous potency of a material. Its toxicity is evaluated in toxicology laboratories and is always expressed in quantitative terms such as lethal concentration 50, which is abbreviated as LC50, the concentration at which a material will kill 50% of some of the reference organisms. Hazard, on the other hand, depends not only on the toxicity of a material but also on the risk of toxic exposure when used. In simple terms, remember that toxicity is the capacity of a substance to produce illness or death. Hazard is a function of toxicity and exposure. Together, toxicity and hazard information can be used to determine a risk. There is a greater potential for harmful effects to humans from highly toxic pesticides than from pesticides that are less toxic. However, the concentration of the pesticide in a formulation, the length of human exposure to a pesticide, and the route of entry into the human body are equally important in the potential for poisoning. Although a pesticide applicator will have little control over the toxicity of a pesticide, he or she will have a significant control over hazards associated with pesticide use. A sealed container of a very toxic pesticide presents little hazard to a pesticide technician before the seal is broken. Even when the container is opened, the hazard may be small if the technician is wearing a protective clothing, gloves, and an eye protection. However, if the container is leaking or if the technician is not using protective gear, the hazard can be high. Moving to the second aspect, Types of toxicity. Toxic effects can range from slight symptoms like minor skin irritation or hay fever like symptoms of headaches or nausea. Organophosphate pesticides and some herbicides can cause severe symptoms like convulsions, coma, possibly even death. Pesticide toxicity in humans can be classified by the nature of exposure, by the route by which the exposure occurs, or by the body function or the system affected. Generally, any poison is more toxic if ingested by mouth than if inhaled, and more toxic if inhaled than if it is by dermal exposure. Poisons work by altering normal body systems or functions. Thus, toxicity can occur in as many ways as there are body functions. Poisons can affect just one particular organ system, or they may produce generalized toxicity by affecting a number of systems. Some toxic effects are quickly reversible and do not cause permanent damage. Others may cause reversible damage, but complete recovery may take a long time. Still other poisons may cause irreversible damage, even if the exposure is not fatal. Classification by type of exposure. Toxicity can be divided into 4 types based on the number of exposures to a poison and the time it takes for toxic symptoms to develop. These 4 types may be combined with the classification based on the route of exposure discussed below. They are acute toxicity, chronic exposure, subchronic exposure, and delayed toxicity. Moving into the first type, acute toxicity. When a person is exposed to a single dose of a pesticide, it referred to as an acute exposure. Further, if the exposure is by contact with skin, it would be regarded as an acute dermal exposure. Acute oral refers to a single dose taken by mouth, and acute inhalation refers to a single dose that is inhaled. Next is chronic exposure. When there is repeated or continuous exposure of a pesticide by a person, it is called chronic exposure. This toxicity can be described in terms of chronic dermal, chronic oral, or chronic inhalation toxicity. Next type, subchronic exposure. When there has been repeated or continuous exposure to a pesticide but no measurable toxic effects have resulted, a person is said to have been subjected to a subchronic exposure. Lastly, delayed toxicity. Delayed toxicity may occur many years after exposure to a chemical and is most often only discovered by retrospective epidemiological studies. Some chemicals that produce delayed toxicity are fipronil and asbestos. Epidemiological studies are crucial to the detection of further occurrence of delayed toxicity. Next is classification by body system affected. Cutaneous toxicity. Cutaneous toxic reactions are most often associated with petroleum-based products, pyrethroids, and some herbicides. These reactions account for approximately 1/3 of all the pesticide-related occupational illnesses. Dermatitis is the term used to describe and skin rashes associated with inflammation and redness. There are many different types of dermatitis. They differ in appearance and in how they are caused. Among agricultural workers, dermatitis may be caused by exposure to non-work related irritants or to crops, plants or pesticides. Cutaneous toxicity can be further characterized by a specific response of the skin. They are primary irritant dermatitis. It is also abbreviated as PID. This type of dermatitis is caused by chemical substances that directly irritate the skin. Primary irritant dermatitis effects may be relatively minor with only minor irritation or may be very severe with blisters or ulcerations. Areas directly contacted by the irritant are usually most severely affected. Herbicides are the pesticides that most frequently cause primary irritant dermatitis. Exposure to pyrethroids can cause a crawling or tingling sensation in the skin and may irritate mucous membranes. Next is allergic contact dermatitis. It is also abbreviated as ACD. This type of dermatitis is caused by chemical substances that stimulate development of an allergic reactions. Workers may handle an allergic substances for the years before allergic contact dermatitis develops, or it may develop after a single exposure. Symptoms vary from redness and itching to a large painful blisters. Nalate and malathion exposure may result in allergic contact dermatitis. Classification by route of entry. There are 4 common ways in which pesticides can enter the human body through the skin, the mouth, the lungs and the eyes. The chances of pesticide entry into the body is affected by the state of the chemical, that is, as a solid, liquid or gas. Liquids or gases can penetrate the body via any of 4 routes. Solids tend to have a lower chance of entry through the lungs or eyes, but if solid particles are small enough or if they remain on the skin long enough, entry is possible in the same ways that liquids or gases can enter. Next is oral entry. This type of entry is through the mouth in the food we eat or the liquids we drink. Also, if there is any pesticide on our hands, it can get into the body when hands are licked, when the face is wiped near the mouth, or when a cigarette becomes contaminated and is put into the mouth. Next is respiratory entry. Pesticide sprays, vapors or powders can be breathed in through the mouth and nose. Next is dermal exposure. Absorption through the skin is the most common route by which pesticide applicators are poisoned by pesticides and other chemicals. Dermal absorption may occur as a result of a splash, spill or a drift when mixing, loading or disposing of pesticides. It may also result from exposure to large amount of residue. The degree of dermal absorption hazards depends on the dermal toxicity of the pesticide, the extent of the exposure, the way the pesticide is formulated and the part of the body contaminated. Certain areas of the body such as the male scrotum are more susceptible to pesticide absorption than other areas of the body. Coming to the third aspect, pesticide residues. Whenever pesticides are applied, their residues will remain on treated surfaces for a time. The chemical properties, frequency of the application, rate applied and the environmental factors determine how much residue will be present. Residues are an important in certain circumstances and necessary for some types of pest control where their presence provides continuous control. Herbicides applied where crop rotation is not a factor or in the areas where total long-term weed control is desired, such as fence rows and adjacent to buildings. Protecting structural foundations from termites is another desirable feature of pesticide residues. However, residues are undesirable when they expose to people, domestic animals or wildlife to unsafe levels of pesticides. Pesticides that move off-site or miss the intended application site can remain as residues in soil, water or on surfaces. Also, pesticide containers can hold small amounts of residues that require proper cleaning and disposal to prevent environmental contamination. Acceptable levels of residues for any pesticide are known as its tolerance, which is the maximum amount of a pesticide that may remain on or in the raw agricultural commodities. Government agencies set these acceptable levels. Research is conducted using laboratory and animal tests to establish tolerances. From this research, amounts of pesticides that remain are determined to be harmless to consumers. A conservative margin of safety is included in the tolerance levels when established by the Environmental Protection Agency, which is abbreviated as EPA. Each pesticide that is registered for a food use must have an established tolerance, and their levels will vary depending upon the pesticide's mode of action, toxicity and all uses of the pesticide. In establishing the tolerance of a pesticide, researchers considered the total diet of the consumer and their non-food exposure throughout a lifetime of 70 years. State and federal agencies monitor produce to ensure that growers do not exceed pesticide residue tolerances. Any produce that is found to exceed a tolerance is seized. Occasionally, pesticides can be erroneous present due to the crop absorbing pesticides that were applied to the site previously, a grower applying pesticides to an unregistered crop, a grower applying a rate of pesticide that exceeds the label recommendations, the pesticide is applied too close to the crop's harvest or drift of a pesticide from another site. Post-harvest use of pesticides can also leave residues on the produce. Improper use of pesticides in warehouses, markets or restaurants may also leave illegal residues on the food products. According to a survey by the Food Marketing Institute, food safety was identified as a #1 issue that can affect a retail operation. Although very rare, excessive pesticide residues on food products are a concern. The persistence of a pesticide is the amount of time from its application until its breakdown. Certain pesticides do not degrade rapidly in the environment, thus they would be referred to as a persistent. Some of these pesticides, such as many of the chlorinated hydrocarbon insecticides, were banned for the use once these characteristics were determined. Undesirable features of persistence include the potency for pesticide exposure. Some pesticide labels will require long restricted entry intervals, and the increased chance of the pesticide leaving the treated site through water movement, leaching and wind. Persistence may restrict growers from planting certain crops on a previously treated site. Regulations establish plant back restrictions to prevent injury from residues to consequent crops. When these restrictions apply, the pesticide label will specify which may be grown or those which should be planted. The label will also state how long after application a grower must wait before planting other crops. Plant back restrictions are a good reason for keeping accurate pesticide application records. Moving to the fourth aspect, pesticides' effect on humans. The exact way that pesticide poisoning can affect humans and the degree to which certain segments of the human population can be affected are not completely understood. However, the signs and the symptoms of acute pesticide poisoning are well known. Symptoms are what a person feels and can express to others. Signs are things one person can observe in another person, even if that person is unconscious. Pain and nausea are symptoms. Redness of skin, swelling, and hot, dry skin are signs. You should learn and be alert to the signs and symptoms of the early stages of poisoning. If any sign of poisoning develops, you should immediately and completely remove the source of exposure. By doing so, you may prevent additional exposure and minimize injury. Early recognition of the signs and symptoms of pesticide poisoning and immediate and complete removal of the source of exposure may save a person's life. This is especially critical if a person is unconscious or otherwise unable to communicate clearly. However, remember that the signs and symptoms of pesticide poisoning can also be caused by other factors such as infectious diseases or exposure to other chemicals. Therefore, it cannot be assumed that because an individual is in the vicinity of pesticides or a pesticide applications, the development of some signs or symptoms of poisoning are necessarily the result of pesticide exposure. Nevertheless, if any signs or symptoms appear after contact with pesticides, you should contact a physician for assistance without delay. Next is symptoms of pesticide poisoning. Some products with high potential for human poisoning fall into these groups. The signs and symptoms associated with poisoning should be well known to the pesticide applicators. Organophosphate pesticides. Organophosphate poisons attack themselves to a chemical in the blood that is normally present and necessary for proper nerve functioning. This chemical is an inhibitor of enzyme cholinesterase. The organophosphate pesticides bind to the enzyme and make it unavailable to the nerve connections. When cholinesterase is unable to perform its normal function, the nerves in the body fail to send messages to the muscles properly. In such cases, the muscles may receive continuous or erratic stimulations, leading to twitching and constant contractions. In case of severe poisoning, quick and proper medical treatment may reverse the effects of the poisoning, and the life of a person can be saved even in advanced states of poisoning. Next is carbamate pesticides. The mode of action of carbamates is similar to that of organophosphates, and they also inhibit the enzyme choline esterases. The signs and symptoms of carbamate poisoning are essentially the same as those caused by the organophosphates, but carbamates are broken down relatively rapidly in the human body. Consequently, the effect of carbamates or choline esterase inhibition is relatively brief. Because of this, blood test on choline esterase in people suspected of pesticide poisoning may not be an accurate indication of carbamate poisoning. Organochlorine pesticides. No compounds in this group are currently registered for public health uses in California. The organochlorines act on the central nervous system. Many of these compounds and their degradation products can be stored in the fatty tissues as a result of either large single doses or repeated small doses. Single large doses can cause liver and kidney damage in animals. Symptoms of organochlorine pesticide poisoning include nervousness, nausea and diarrhea. Next is botanical pesticides. Pesticides derived from plants vary greatly in their chemical structure and also in their toxicity to humans. The toxicity of these pesticides ranges from pyrethrum, which is one of the least toxic of all insecticides, to mammals, to strychnine, which is one of the most toxic. Pyrethrum. Pyrethrum is a natural botanical pesticide containing the active ingredient pyrethrin. These pesticides are among the least toxic to mammals, that is LD50 in rats about 1500 mg per kilogram. Next is strychnine. Strychnine is an alkaloid that will kill a wide variety of vertebrates and invertebrates. Strychnine is rarely used because of the potential for non-target and secondary effects. Strychnine is not currently used for vector control. It is registered in some states including California for the mole and gopher control. It has an LD50 in rats of about 1 to 30 mg per kilogram. It is included here for comparison with pyrethrum, another botanical pesticide. Next is pyrethroid pesticides. These are synthetic pesticides with chemical structures similar to pyrethrins. Because of this, they are called pyrethroids or pyrethrum-like. Pyrethroids exhibit a wide range of toxicity from very low to very high. Pyrethroids used in public health applications include permethrin, resmethrin, sumethrin, cyperethrin, cyfluorethrin, deltamethrin, lambda cyhalothrin and others. However, in aquatic environments, these materials can be considered very toxic to fish and other organisms. In EPA toxicity test 96-hour, that is LC50 values of less than 1 microgram per liter have been found for some organisms. Resource agencies will usually use these low values when establishing relative risk evaluations for pesticides or other chemicals. Next is fumigation materials. The only material considered as a fumigant is used in vector control is zinc phosphide. It is a rodenticide. Chloropicrin is used as a soil fumigant to kill soil insect pest, and aluminium phosphide is used to control stored grain insects. All fumigants are extremely toxic when inhaled, but those listed above have no dermal toxicity and are very easy to work with when wearing appropriate safety equipment, a cartridge, respirator and eye protection. Hence, we can conclude this episode by pesticides are widely used in agricultural production to prevent or control pest, diseases, weeds and other plant pathogens in an effort to reduce or eliminate yield losses and to maintain high product quality. Although pesticides are developed through very strict regulation processes to function with reasonable certainty and minimal impact on human health and the environment, serious concerns have been raised about health risk resulting from occupational exposure and from residues in food and drinking water. Thank you.